Welcome to NLPCraft video tutorials. Apache NLPCraft is a Java-based open source library for adding natural language interface to modern applications, enabling people to interact with your products using voice or text. In this quick video, we'll cover the download, installation, and running one of the built-in examples to verify our installation. To download, go to nlpcraft.apache.org and click on a download link. Notice there are many ways to get NLPCraft. You can download zip archive for the source code only official Apache release. You can also download convenience binary builds. You can clone and build Git repository, or just add Maven dependency to an existing build toolchain of your choice, like Maven, IVSBT, Gradle, or Grape. Let's click on the latest version and save it to the local file system. For the purpose of this video, we've downloaded the official Apache release that contains source code only. Once downloaded, unzip it first. Once unzipped, we need to run Maven build, making sure that to include examples profile, since we're going to be using examples in this tutorial. The build can take a few minutes to complete. Let's go ahead and switch to a folder where we've just unzipped and run a classic Maven build. Making sure we include example profile, we also skip tests. Note that you can skip this step if you've downloaded the binary release instead. As I mentioned before, you can also add NLPCraft directly as a Maven dependency using various build tools to an existing project. Once everything is built, let's run one of the examples that is bundled with NLPCraft to verify that the installation is valid and everything is working as expected. Before running this example, let's review the main components of the NLPCraft Runtime Architecture. We will use this diagram from the overview section of the documentation. Let's start with the data model. NLPCraft employs a model-as-a-code approach, where the entire data model is part of your source code. Data model is simply an implementation of a Java interface that can be developed using any JVM programming language, like Java, Scala, Kotlin, and Groovy. Data model defines named entities, various configuration properties, as well as intents to interpret the user input. To make use of data model, it has to be deployed in a data prop. Data prop is a lightweight container designed to securely deploy and manage user data models. Each prop can deploy and manage multiple models, and many props can be deployed and connected to the REST server. The main purpose of the data prop is to separate data model hosting from managing REST calls from the client applications. While you would typically have just one REST server, you may have multiple data props deployed in different geolocations and configured differently. Data props can be deployed and run anywhere as long as there is an ingress connectivity from the REST server, and are typically deployed in the DMZ or close to your target data sources, on-premise, in the cloud, etc. Now, the data props use strong encryption and ingress-only connectivity if you're communicating with the REST server. And finally, the REST server, the component that provides URL endpoints for the end-user application to securely query data sources using natural language via data models deployed in data props. Its main purpose is to accept REST over HTTP calls from end-user applications and route these requests to and from requested data props. Unlike a data prop that gets started every time the model is changed, for example during the development, the REST server is a sort of a fire and forget component that can be launched just once, while various data props can continuously reconnect to it, and can typically run as a Docker image locally, on-premise, or in the cloud. With that brief overview in mind, let's jump back into running our example. For the purpose of this tutorial, we'll use the light switch example that provides a natural language interface for a typical light switch in your house. This example comes with NLPCraft and provides identical data model implementations in 4 different programming languages that you can select: Java, Scala, Groovy, and Kotlin. We'll use the Scala version for our demonstration. To manage our runtime components, the REST server and data props we just described, we'll use a very handy NLPCraft command line utility that is available for both Unix, Linux, and Windows environments. Let's go ahead and start NLPCraft script. By default, it starts in interactive REPL mode. First, we're going to start the REST server using the start server command. This command starts the local server with the default configuration. Once the server is started, let's go ahead and start data prop with our model. Remember, we're going to be using Scala-based implementation of the light switch example. We use a very similar start prop command. Here, however, we need to specify a couple of additional parameters, such as additional class path, where our model implementation is located, and a fully qualified class name of that model. So let's go ahead and start the prop. Class path is located in following subfolder, and I believe it's this. And we need to specify a class name for the data model. Note that NLPCraft script has intelligent auto-completion and suggestions for paths, commands, and data parameters, dramatically simplifying the usage. Once data prop is connected and started, it actually auto-connects to the REST server and all our runtime components are started and wired together. At this point, we can go ahead and start testing our model using the REST calls. To test using REST calls, we'll be using the same NLPCraft script. It provides a very convenient command, ask, that allows us to issue the REST calls to the server with a minimal setup. If you ever forget about the commands and which commands are available, you can always type help and get a full help on all the commands. So we're going to use the ask command. And we can basically ask some interesting commands for our light switch example. We can turn on the lights in the kitchen. And we get a response back. Essentially, if you look at the response body over here, you can see that the lights are on in the kitchen. We can actually play a little bit more with this and kill all the lights in the house if we like it. And yes, lights are off in the house. Well, everything seems to be working properly, and our installation and verification is complete. Remember that you can review this and other examples on the website. You can also view this entire source code for this example on the GitHub. Thanks for watching.